Hey everyone, so we are in the study design unit in the statistics and probability class on Khan Academy. And what we're going to do is take a look at quiz 1. So I've taken this a few times now. A lot of the questions are pretty tricky because it's testing concepts where they're very close to each other or where it's being very, very, very specific about the definition of things like what a population is and what a sample is. So the last time I took it, I got them all right, but the first two times I got 4 out of 5. So I'll take it one more time here. The questions will be different, and I'll see if I can get some good explanations and try to get the concept nailed down and give good explanations for why, and hopefully get 100 here. All right, so let's check it out. All right, so this one says a city council member wanted to know how her constituents felt about a planned rezoning. She randomly selected 75 names from the city phone directory and conducted a phone survey. Okay, so what they're asking about is the population and sample. So thinking about this situation, so for reading here, we only have A, B, and C as options. So I'm just going to read it one more time. And what I'm going to do is just think about what might the population be and what might the sample be. What might the population be? What might the sample be? So the population, those are all the people we're interested in learning about. And every person in the population should have an equal chance of being selected. So in this case, because we're looking at a phone directory, we can only consider people in the phone book as the population, right? Because those are the only people that had a chance of being selected, and every person in the phone book had an equal chance of being selected. So to me, it seems like the population is going to be anyone that's in the phone directory, and the sample is going to be these 75 names. So let's read the answer choices. Answer 1, the population is everyone listed in the phone directory. I like that. And the sample is the 75 selected. So I think that's going to be correct. Let's see. The mouse. All right. B says the population is residents of the city. The sample is the registered voters. So even I think the sample is the very clear one that's off here. It says here she randomly selected 75 names. So the sample, the people that she selected from the population are those 75 specific people. That's why I like A a little more than B here, where because the sample is not all registered voters. It's the specific 75 selected. For C, the population is registered voters. The sample is everyone listed in the phone directory. That's not quite right. The sample is not everybody listed. There's only 75 specific people that we chose in the sample. And those people were selected from a phone book. So the population they were selected from is the phone directory. And the sample was the 75 people from that phone directory. So I'm going to go with A here. All right, very nice. All right, let's clear drawings. All right, so this one says, a large random sample of American students in 7th grade showed that 20% of them were reading below grade level. So a random sample of American students, that's impressive. So they got an entire list of all 7th graders in America, and they took a random sample from that list. And 20% from that sample were reading below grade level. So what we're probably going to think about, it's asking about valid conclusions. So what conclusions are valid? So what's going to be important is understanding that these students were American. So we can't make statements about students all over the world because the population was just Americans. And they're also in 7th grade. So we can't make statements about students in other grades. We can really only make statements about American 7th graders. And because it was chosen randomly, it seems like we can actually make statements about that population because the methods were done properly. So based on the data, which of the following conclusions are valid? So A says about 20% of all American students in 7th grade were reading below grade level. I like that. So it uses the sample that it took to make a statement about the population, and the population is all American students in 7th grade. So I'm going to click that for now. B says 20% of this sample was below grade level, but we cannot conclude anything about the population. So it's true that 20% of the sample was below grade level, but because this was a large random sample, that's the key here. So if you're taking a large enough random sample, you can make statements about the population that you drew from. So as long as you're drawing randomly from the population and your sample is large enough, things are going to work out well for you. So B is it's not saying enough. We can actually say more. We can make conclusions about the population because it is a large random sample. And C says about 20% of all American students were reading below grade level. So the key thing here is that in C, it's talking about all American students. We can't say that because the population that we drew from was 7th grade students specifically. So that's why I'm going to go with A. All right, let's clear your drawings. All right, so this says Jordan Michael runs a basketball camp. A group of randomly selected camp participants were asked to give their shirt size. The table below shows the results of the survey. There are 308 camp participants this year. Okay, so what I like here, just reading through the question, it says a group of randomly selected participants gave their shirt size. So that just basically means we can trust the results here. We can trust that this sample is going to represent our entire population. Because if you look at this sample, this is not 308 students altogether. The 6 and the 4 will give you 10, plus 15, so that's 25, plus 35, so that's 30, 40, 50, is that 60? So I believe that's 60 total people. So out of 60 people, let's see what it's asking us. Out of 60 people, like 6 people were small, 15 were medium, and so on. So these were the results out of a sample of the size 60. And all we're going to do is say, okay, whatever percent of the sample, so this 6 is 10% of 60. So we would assume that 10% of these 308 people will also have small shirt sizes, the same percentage, the same relative percent. So I'm just going to clear my drawings and go down to the question because we actually haven't seen a question yet. And this is asking, based on this data, what is the most reasonable estimate for the number of this year's camp participants who will wear a medium shirt? All right, so let me get my drawing tool out here. And I believe it said there are 308 participants overall, and this is a sample of 60. And you can check my math on that. Hopefully I added that up right. So I'm saying a sample of 60. And the question is, how many of the 308 participants can we expect to wear a medium shirt? So in the sample, it was 15 out of 60, and that is 25%, 15 divided by 60. So you can just take the number of mediums and divide it by the whole sample. And this is, if you put this in your calculator, you'll get 0.25, which is the same as 25%. So now if we take this 0.25 and multiply it by 308, so we do 308 times 0.25, we're figuring out what 25% of 308 is. And let's do that in the calculator. So 308 times 0.25, I'm going to clear my drawings. All right, 308 times 0.25. And you can estimate this as well, and you'd probably get your answer. So let's do 308 times 0.25. Oops. So sometimes the calculator is really stressful on this. What I do, if you're struggling with the calculator, I just pull up a browser and Google does the calculator for you. So I'll say 308 times 0.25. I don't know why the calculator doesn't work sometimes. And 77 is the number here. The other way you could have estimated that is we're finding 25% of 300. So you can find 25% of 100, which is 25, and then multiply that by 3, which is about 75. And that's another way to get an answer right around 77 or right around 75. And it should be a little higher than 75. And with these answer choices, you could have estimated your way to 77. All right, so the next one. Okay. All right, so these are some of the questions that can be tricky because you have to understand what Khan is asking or what is the Khan Academy site asking. So, and it comes down to the way they've taught this in the video. So let's read the question, talk about and their definition of what a statistical question is. So it says, determine whether the following is a statistical question. It says, how many text messages have you sent today? So what I'm going to think about is how would I answer this question? So if I wanted to answer this question, how many text messages have you sent today? And let's pretend it's me. I would go into my phone and I would count the number of text messages and there would be one answer. And let's say it's, 15, right? So that is one answer. It's one number. And actually all I'm doing is I'm just counting something. So that is not using statistics. With statistics, what they're saying is that you have to collect data with variability. You have to collect data with variability. So for example, if I asked, do teachers send more texts on average than students? So if I wanted to answer that question, I would have to go around to a bunch of teachers, maybe randomly select some teachers, randomly select some students, and I would collect their averages maybe, or I'd look at a graph of how many texts they've sent. But the idea is if I wanted to answer that question, I would need to collect data, and that data would have variability. The data would be different. There'd be lots of different numbers going on. I'd be collecting a diverse set of numbers. With the question that they're asking here in this question, it's not quite like that. You're actually just counting one specific number. So you're not collecting data with variability. You're just collecting one specific number, one specific statistic. You're really just counting here. So this is not question that requires the use of statistics. Anyone can answer this question without knowing anything about statistics. But if you want to answer the question, do teachers send more texts on average than students? You're going to need to know some of the methods of statistics in order to answer that. So we'll say not statistical. All right. So let's clear last question here. So we're going 4 out of 4. Let's get 5 out of 5. So this one says a safety inspector conducts air quality tests on a randomly selected group of 7 classrooms at an elementary school. Identify the population and sample. So let's read it one more time. A safety inspector conducts air quality tests on a randomly selected group of 7 classrooms. So he's picking classroom, or the inspector is picking classrooms. So the population is, I guess, all the classrooms at this school, and the sample is these 7 classrooms. So let's find that answer. All right, so we have A, B, and C here. A says the population is all classrooms in the district. The sample is the 7 selected. So I like that the sample is the 7 classrooms selected, but the population, I don't believe that it's all classrooms in the district, because the inspector is randomly selecting 7 classrooms at a specific elementary school. So I believe it's only classrooms at the school. So I'm going to say A is wrong. B says the population is all classrooms in the elementary school. That is the same thing I just said. And the sample is the 7 classrooms selected. I like that one. And C, the population is all elementary students in the school. So the safety inspector is not randomly picking students. They're randomly picking classrooms in a school. So that's why I like B more than C. And the sample is 7 classrooms. So C is saying that the sample is the students in the 7 classrooms. B is the more correct answer here. I'm going to go with B. All right, very nice. So hopefully this helps. Please ask questions either by email or in the comments if you're watching on YouTube. So just let me know if there are any points of clarification, and I can try to answer those questions. I hope this helps. All right, bye.